Hi friends, again welcome to Jnana Learning. So continuing the lecture on VHDL, it's part 2, modeling a circuit. So how can we model a circuit using VHDL? Based on the 3 levels of abstraction, there are 3 styles of modeling a particular circuit. So which are the 3 levels of abstraction? Data flow, behavioral and structural. So based on that, we have 3 styles of modeling a circuit, that are data flow modeling, behavioral modeling and structural modeling. So first one, that is data flow modeling. So in this modeling, it expresses the functionality of a circuit as a flow of data, and it does not use the structure or components but uses the logic expressions to express the flow of data from input to output through intermediate interconnections. Okay, so in this case the structural components are not considered, but the logical expressions of that particular circuit are considered in data flow modeling. And the second one is behavioral modeling, and here it expresses the behavior of the circuit, that is the behavior of the output with respect to changes in input without going into details of the component. Okay, and it is a sequential style of modeling, that is order in which the statements are written is important in this case. Okay, so that's the behavioral modeling of a circuit. And finally the structural modeling. So here it represents a circuit in terms of interconnected components. Okay, so components are considered over here. In this modeling, architecture body consists of 2 parts, that is a component declaration and component instantiation. Component declaration means each and every components to be used in the architecture description is declared with its unique name, with an identifier, its number and type of input and output ports. And component instantiation means mapping between actual and formal parts of the entity and the component. So the component declaration and component instantiation constitute the architecture body in structural modeling. Okay, so these are the 3 modeling styles in VHDL for modeling or designing a particular circuit. Now let's study how to model a half adder using these 3 styles of modeling. Okay, so before that we have to know the half adder circuit that you have already studied. So for a half adder we have got 2 inputs and 2 outputs. The outputs are sum and carry, and the logic circuit for half adder is in such a way that we have 2 components, that is an XOR gate and an AND gate, and the expression for sum is S is equal to A bar B plus A B bar, that is XOR A XOR B, which is a sum, and the carry, which is the output from the AND gate, which is equal to C is equal to A dot B. Okay, so that's the half adder. Now we can model this half adder using data flow modeling, behavioral modeling and structural modeling. Okay, so how can we model a half adder using data flow modeling? Before that, you have to be thorough with the syntax of entity and architecture, writing the entity and architecture. Okay, so we can start entity, then the entity name, which is actually we are modeling a half adder, so entity name is given as half adder. Then is, and the next line, that is port, then A comma B, which are the port names, in, which is the mode, and bit, which is the type. Okay, then we have the output ports, that is sum and carry, which are the again the port names, output port names, and out represents a mode and bit represents the type. Okay, so A, B, sum and carry are of bit type. A, B are in mode and sum carry are the out mode. Then entity ends with end keyword and then the entity name, again half adder. Okay, so it's clear. So the keywords are written in bold and caps, and all other, the half adder, it is the entity name. A, B and sum carry are the port names. Okay, in and out are the mode, and bit is the type. Then the architecture, then data flow. Data flow, it is an architecture name, again of, and half adder is again the entity name is. Then begin, then we write the statements in architecture, that is sum is equal to A XOR B, and carry which is equal to A and B. These are the statements to be executed in within the architecture. And architecture ends with end, the keyword end, and again the architecture name data flow. Okay, so is it clear? The modeling using data flow modeling, modeling of a half adder using data flow modeling. Okay, so next is the behavioral modeling of half adder. So again we start with entity, then half adder is, so half adder is the entity name. Then port, it is a keyword. Then A comma B, which are the port names. In bit, in is a mode and bit is a type. Then sum and carry in output port, out means the mode and bit is the type. And the entity part ends with the keyword end and the entity name half adder. Okay, it is similar to that of the data flow modeling. Then in architecture part, we start with the keyword architecture, then we use the name behave just to represent it is a behavioral modeling. That's all. Behave is architecture name of half adder is. Half adder is the entity name. Then begin, keyword begin is used, and next is a keyword process. Okay, then within the brackets A comma B, which means process A comma B, process the input. Okay, so here the behavior of the circuit is considered, and we have used the keyword process. Process A comma B means process A and B, process the inputs A and B and give the output. Okay, then again the keyword begin, then we have the statements, that is sum is equal to A XOR B and carry is equal to A and B. Then we have to end that particular process, then end process, and finally end behave. That's end the architecture with the architecture name behave. So is it clear? So all the keywords are given in bold and in caps, and we have to consider the behavior of the circuit. For that we have used the keyword process A and B. A and B are the inputs, and we have written the statements to be executed. Okay, so that is a behavioral modeling of half adder. And finally the structural modeling of half adder. Okay, so in this case we have to consider the components used in a half adder circuit. So which are the components used in a half adder circuit? AND gate and XOR gate. So we have to consider that AND gate and XOR gate while writing the program, or while considering the modeling of half adder using structural modeling. Okay, so the entity part is similar to that of data flow and behavioral modeling, that is entity half adder is, then port A comma B in bit, then sum comma carry which are the output, and ends with half adder. This is the entity name. Okay, now in architecture we have used the keyword struct to represent that is a structural modeling of half adder is. Then we have to declare that particular component AND gate using a keyword component, then AND gate is. Again the port for AND gates, which are, there are two inputs for AND gate which are represented as X comma Y in bit. In represents the mode and bit represents the type. Then one output from AND gate, that is set, which is the output bit. and we end that particular component using the component name AND gate. Then which is the second component in a half adder circuit, it is the XOR gate. So next component, that is XOR gate, is then the port. Again, for XOR gate there are two inputs and one output, and that two inputs are represented as L, M in bit and N, which is an out bit. Then we have to end that particular component using the component name and XOR gate. Okay, now begin. Now we have to write the statements as two statements. First statement is written in such a way that X1, capital X1, we have to port map that particular component with the inputs to the half adder and the output. The inputs and outputs of the half adder have to be port mapped with the components. Okay, that is the way in which we write the statements. So capital X1, then XOR gate, first component we have to port map with the input A and B. So using the XOR gate we get the sum. Okay, and second statement which is written in A1, that is using the AND gate, we are port mapping the inputs to the half adder A and B with the component AND gate, and we get the carry. Okay, so is it clear? That is, we were port mapping the inputs to the half adder A and B with the XOR gate to get the sum, and we are port mapping the inputs to the half adder A and B with the AND gate to get the carry. And finally we end the architecture with the architecture name end struct. Okay, so that is the structural modeling of half adder. Okay, so that's about the modeling of a circuit. So we continue the lecture on VHDL. Next part, it is identifiers and data objects. So thanks for watching the video. Watch the next lectures on VHDL, and for watching more videos on electronics and communication subject, please subscribe our channel Jnana Learning. Thank you so much.